Greetings, students. This is part 2 of the final review, and we'll be starting with this section that's labeled adding and subtracting expressions. And in the current notes packet, this is labeled F6. F6. Adding and subtracting expressions is where we're going to start. So, remember that when we're adding and subtracting, we are combining like terms. And so I can put together this 7x and the 5x. They are like terms, so that makes 12x. And then we can also put together the two constants, the +1 and the -6, to make -5. And then that's as much as we can do, right? So we're just combining those like terms. So not so different than what we've seen before. So get those variable terms together, 19n, get these constant terms together, -27, -8, two negatives, I'll add them together to get a bigger negative. Now, if it is subtraction, remember we can treat that as if we are distributing one there, a -1, so that this becomes -9i, and it also becomes -2. Then the 3a and the -9a, I think I said I before, sorry about that, is -6a, and the -15 and the -2, -17. So just remember the one after the minus sign, that's going to change both of these signs. So that becomes -5, but plus 9w. So then -w and 9w, that's like a -1w. It is a -1w. That makes 8w, -19 and -5, -24. So we're just combining the like terms. These are not equations. There is no equal sign at the beginning. So please don't be tempted to go too far and actually try to solve. As you can see, I've skipped on down a little bit to this one that is talking about the lengths of the sides. All right, so it says the length of the side C is one less than twice A. So C is equal to 1 less, so I'm subtracting 1 from twice A. So this is kind of this is one that we are having to do some translating, and then we'll be doing some combining like terms after that. So C is the same as 1 less than twice A. B is equal to 4 more than C. Well, we just said that C is 2A minus 1, right? This whole thing is C. And B is 4 more than that. And then, of course, A is A. A is itself. So if I want the perimeter, I have to go all the way around this triangle. So I would have A plus, if I go around this way, this is my A. B is 2A minus 1 plus 4. B is 2A plus 3. C is 2a minus 1. So it may help to write those things on the diagram. And then now if I add all the way around, doesn't really matter what order I write these down in, but I will combine my like terms to get 5a plus 2. So 1, 3 makes 5. 3 minus 1 makes plus 2. All right, so next section, again, I won't be going over every one of these questions. So adding and subtracting these monomials, remember it's still adding and subtracting, so you're just combining like terms. You do not change the exponents when you're adding and subtracting. You can only put them together if they have the same variables and the same exponents. And then I'm doing that. This says sum, so I am adding. And then I'm doing that by just combining or adding, in this case, those coefficients. And then the variable part just stays the same. Now, when this says subtract this from that, that means we have this subtract negative w to the fourth. So if I subtract a negative, that actually turns into addition, but these are opposite signs. So then the next part, when we're multiplying and dividing, remember that we add the exponents when we're multiplying if they have the same base. So this I would just rewrite as 14 to the 9th power. If it doesn't have an exponent, it's understood that it starts out with its exponent being a 1. So the r exponents would get added together, and the s exponents would get added together. Please remember, as we've talked about before, that your coefficients still behave like normal numbers. So when it's multiplication, negative 3 times negative 9 is still going to be positive 27. It is the exponents that get added together. When we multiply by a fraction in number 7, that is multiplying by the top of the fraction and dividing by the bottom. That's what multiplying by a fraction does. That negative sign on the 5/8 can be attached to the 5 or the 8, but not both. So I can do negative 5 times 16 is negative 80. Divide it by 8 makes that negative 10. So I just did this, basically making that 16 over 1. And then the exponents, when we're multiplying, would get added together. So the coefficients were actually still multiplying. The exponents were being added. For division, division is the opposite operation of multiplication, so it should make sense that we subtract the exponents. Again, subtract exponents that are on the same bases. So this would be negative 3 still, and then 16 subtract 4, 12th power. And that's where I would want you to leave that. So here, I look at my m's. Higher power is on top. 6 minus 2 is 4. I look at my n's. Higher power is again on top. 30 minus 6 is 24. And then actually this is not going to be a fraction because everything had a higher power in the numerator. Remember, if something has a higher power or the bigger coefficients in the bottom, that it could still be written as a fraction. But if everything's higher on the top, it won't need to be a fraction anymore. 21 over 36. We still need to divide or reduce the fraction part, the coefficients. So 21 over 36, I can reduce that by dividing the top and bottom by 3. That's the best I can do. So that would be 7 over 12. And then the higher power of W is in the top. And I do 10, subtract the first power of W on the bottom, makes that 9th power. So my coefficients, my big numbers, are not going to behave the same as my little numbers, my exponents. Negative 84 divided by 12 is negative 7. Subtract the exponents on the r's, so 8 minus 4 is 4. And then subtract the exponents on the s's. 21 minus 6 is 15. Again, this did not need to be in a fraction because everything was bigger on the top. All the powers were bigger and the coefficient was bigger. Right, so as I go through these, I might be going pretty quickly, but you can always pause it, get what you need. All right, and again, I probably will not go over every single question, nor would we go over every single question in class. All right, next section, now we're doing the power rule, and remember for the power rule, we are multiplying exponents with the exponent on the outside, and we are raising coefficients to the power. So again, the small numbers and the big number do not behave the same. So in the case of number 12, the 8 is the base. So then 7 times 5, that is 8 to the 35th power. So 13, where I have my variables, now I have exponents, so 6 times 7, 42, b, 2 times 7, 14. So it's like that 7 is getting distributed to both of those exponents. So in 14, we're taking 3 to the 5th power, which is 243, and then we're doing a and doing 2 times 5 for the exponent. So 243a to the 10th. In 15, we're doing negative 10 to the 2nd power, and then the p. This is what's going on. You might not write that all down. I normally probably wouldn't write all of this down, but to show you what's going on, the negative 10 is getting to the 2nd power, which makes positive 100, right? Because negative 10 times negative 10, signs would be the same. P, 7 times 2 is 14. Q, 3 times 2 is 6. So again, that is the power rule. You might notice that I have backed up a bit. When we were multiplying, I didn't mention it at the time, but that multiplying them, that is the product rule, because product is the answer to multiplication. So it's the product rule that tells us to add the exponents on the same basis. And we still multiply coefficients. And when we get, that would be those problems, and we get to number 8, these are division, and division is the quotient rule. And that is that we subtract the exponents. And divide or reduce the coefficients. Because remember, the coefficients are still regular numbers, so they behave like regular numbers. This one has a number to the power, so like if there had been a number in front, like there is in like 10. All right. So just getting you, making sure that you're familiar with those terms, that this is product rule and division is quotient rule. And then the ones where we're raising the power to the power, that was called the power rule. So that you have all three different powers that you are familiar with. There will not be any questions as in depth as this part 4 mixed practice, so I'm going to skip over those. You might be very relieved by that. And then you do need to be able to solve equations. So remember that the goal when we're solving an equation is that we want to isolate the variable, right? We're trying to get the variable by itself, right? And so we use inverse operations. So we're going to always be doing the opposite of what we see that's happening. So when I see 7m is equal to 28, to get rid of that 7, then we will need to divide both sides by 7. And whatever we do to one side, we're always going to do to the other side. When I divide by 7, I get m is 4. So the next one, I'll go to the right. We would need to add 17. So negative 30 and positive 17 would be negative 13. Over here, that undoes the minus 17, so that now p is by itself. If our problem starts out with a fraction, that means it's starting out with division, and to undo division, we will multiply. So over here, that gets rid of the fraction, and then 3 times negative 6 is negative 18. So remember that when we were working with expressions, there was no equal sign, and all we could do was simplify. We can solve equations, okay? Because so when we solve the equation, we're finding the value of the unknown number, right? Finding the value of the variable. So this next one, I need to get rid of that plus 12 because again, we're trying to get c by itself. So I'm going to subtract 12 on both sides. So c is going to equal 15 minus 12 is 3. So far these are just one-step equations. You will have some simply one-step equations to do and to be able to explain as far as on your final. All right, friends, in pausing at some point, I don't know what the last thing was that I actually recorded. So, but it wasn't this. So I set both of these up. And this first one, I had to subtract 17. This next one, I multiplied by 12. Again, I am not sure if the equations were on there. I have to completely start a new recording if I want to go back and check. So, please don't worry about those really long, messy ones with fractions, because I can tell you for certain that they are not going to be something that you need to worry about on your final exam. And so don't worry about these. Please be sure that you can do these one-step equations. Just in case I didn't get those before, I'm going to do a couple of them. If I did, please feel free to fast forward. So here, if I want the k by itself, I would add 8 to both sides. negative 1 would be k. If I want to get rid of this 9, I would divide by 9 on both sides. So remember, when we're solving equations, that our goal is to find out the value of the variable, and we use inverse operations to do that. We're always doing the same things on both sides so that we can get the variable by itself. Again, sorry, I don't know if I already did that. These problems, I did them. I don't know if I was recording, I should say. That would be negative 40. I know, first world problems, right? Times negative 4 times negative 4. So then R is positive 52. So please be careful that you are following the rules for integers, those sign number rules, when you're solving equations also. All right, so and we'll go back to where I was when I realized I wasn't recording. So here we go with Vera. We want to know her value of her car when she purchased it. So I'm going to say X is the value in 2016. So she bought the car in 2016. A year later, it had depreciated. That means the value went down by $2,300. And then it was worth $28,140. So that would be my initial setup. And then to find out how much it cost her at the beginning, we would need to add the $2,300, the amount that it went down in value, add that back on. So she bought it when it was purchased for $30,440. All right, so we want to know how many hours. Oh, well, I will tell you, you will not have a question like this either, with a decimal like this. So that might be a relief to you. But 0.4 times x is equal to 12, and then divide would give you your answer. All right, now let's look at some of these two-step equations. So again, your goal is to get the variable by itself, and we're going to undo the addition or subtraction first, and then undo the multiplication or division. So in the first one, where I'm trying to get that x by itself, that means we're going to add 18 to both sides. So now I have 8x is equal to 56. And then to get rid of the 8, to undo that multiplication, we're going to divide both sides by 8. So x is equal to 7. All right, so pretty similar on the other side. Notice it does not matter which side your variable's on. You're going to try to get it by itself. So to get the variable by itself, I want to get rid of that plus 11. So I'm going to get rid of plus 11 by doing minus 11 on both sides. That gives me one step closer to that m being alone. 16 minus 11 is 5, is equal to negative 5m. Then we can divide both sides by negative 5. So I get negative 1 is equal to m. All right, so those are two-step equations. And then we have a couple more two-step equations that we're going to look at. All right, let's look at these two-step equations. So this first one, we're trying to get the k by itself. I'm going to subtract 19 on both sides. Remember, when I say both sides, I mean both sides of the equal sign. So this is gone. Now I have negative 2k. Don't forget to drag that negative down with it. Is equal to negative 32. So two negatives there added up to a negative. So rather than thinking of that being subtract 2k, think of it being a negative stuck to the 2. It's the coefficient of the k. Divide both sides by negative 2. And then k is positive 16. All right, next up, we've got one with a fraction in it. We're still going to undo that addition and subtraction part first. Then we'll deal with the term that has the variable by multiplying in this case. So first, let's get rid of that negative 17. Since it says negative 17, we're going to add 17. Do the same thing over here. So I have a over 3 is equal to negative 14 plus 17 is 3. And then now I'm going to get rid of that 3 by multiplying both sides by 3 to get rid of the fraction. 3 times 3 is 9. Okay, so you will have a couple two-step equations. One of them will have a fraction in it, and it will be pretty similar to this, where you do want to undo your addition or subtraction first. We can see ones like further down the page where we actually, if there's more than one part, more than one term in the fraction, then we have to multiply first. Okay, this one we would have to do differently. This one we would have to multiply times negative 2 first, because I can't just reach in there and get rid of that 1 while it's part of the fraction. And then that would be negative 12 is equal to y plus 1, and we would take away 1 to get negative 13 equals y. So a little different setup, a little different step order when there's one big fraction. Okay, a few more examples. These are multi-step equations. So for multi-step equations, when I only have variables on one side, well, either way, remember that we need to simplify things, we need to distribute, we need to combine like terms. This is on the same side. Then we do, for these first couple, then we'll go to add and subtract. But then next, if there are variables on both sides, like these two with variables on both sides, then I would be getting the variables on the same side. Then add, subtract, and then last, multiply or divide, which on these we're going to see divide because we're not seeing fractions with these. All right, so to get rid of the parentheses, if there are parentheses, you want to get rid of those first. So I'm going to distribute. So this should be like your simplifying expressions. So it's like I'm simplifying the expression on each side. So this would be 8v minus 36. So I did multiply that, and then I multiplied the 4 times that. And after we've done that, in this case we don't have any combined like terms. And now we can treat it like a two-step equation, add 36 to both sides. Opposite signs, so I subtracted. Divide both sides by 8. And v is 3. So if there are parentheses, we do need to distribute first. So that's going to be our first step in this next one. 31's just going to wait. This n is just going to wait. And then when I distribute this, I want to think of negative 3 times n. So negative 3n. And negative 3 times negative 7 plus 21. So I took this whole negative 3 times both of these. Now this time I do have like terms to combine. N minus 3n gives me negative 2n. Still have the plus 21. And then now that I've distributed and combined like terms, now I have a two-step equation. So I can subtract 21 on both sides. Now I have 10 is equal to negative 2n, and we can divide both sides by negative 2 to get negative 5 is equal to n. All right, so those two problems are examples of multi-step equations, but they only had variables on one side. So I did not have to worry about this step yet, because the variables were only on one side to start with. The next couple problems, I will have to worry about those steps. So, a couple more examples. Again, I'm not going to be able to do all of these. I'm making this video during my lunch. All right, well, I'm going to try this again because I just worked a problem and didn't record it. So, there we go. Whew, you'd think I learned my lesson. All right, we're going to need to get these variables on the same side up here. So I'm going to subtract 6k on both sides. Now I have 3k minus 16 is equal to the negative 28. We now have a two-step equation. So to get rid of negative 16 or subtract 16, we're going to do the opposite. We're going to add 16. Keeping that equation in balance by doing the same thing on both sides. Then the 3k is equal to negative 12. Now we need to divide both sides by 3. And k is equal to negative 4. We won't be doing this equation. So we'll be distributing next. 12 times n, 12 times 3, 8 times n, 8 times 1. Get those variables on the same side. So I'll be subtracting 8n on both sides. Now I have 4n plus 36 is equal to 8. Now we have a two-step equation. Subtract 36 on both sides. And then last step, you got it, divide both sides by 4. So n is negative 7. All right, I hope you found this helpful. Be sure that you are signing up for your time slot so that we can get your final exam done. Please contact me if you have any questions.